Welcome to Project Geospatial. I'm Adam Simmons, and back with me is Dr. Tanya Harrison, aka Tanya of Mars. Tanya, go ahead and reintroduce yourself and give us a rundown of who you are, what you currently do, and we'll kick off the conversation from there.
Sure. So I'm Dr. Tanya Harrison, and I call myself a professional Martian because I've spent the last 10 years working on different Mars missions and science on the Red Planet. But right now I do more earthly things for Planet Labs as their manager of science programs on the federal side of the company. My background is in geology with a specialization in Mars and also earthly analogs for Mars, so things like the Arctic and the Antarctic. And then I also have degrees in astronomy and physics from my undergrad. So I started in the stars, and then I moved my way down to Mars.
And then back to Earth.
And then back to Earth, yeah.
So what does that mean? Why did you come back to Earth? And we'll dive into your Mars experience here, but why come back to the Earth focus?
I figured Earth is in a little bit of a crisis right now, and I felt like I could maybe do some more impactful work if I came back home for a little bit. I guess there could be some debate between my friends which one is actually my home planet, but I felt like I needed to do some stuff here for a little while.
Extremophiles. What does that mean? Looks like that's a question from the chat room.
It sounds like they're asking if I worked on astrobiology. So extremophiles are a specific type of life on Earth that can survive in, as the name would suggest, really extreme environments. So really hot or really cold or really acidic. And we see these as things that would be the most likely creatures to be able to survive on a place like Mars. I haven't done much in the way of astrobiology research other than looking at places on Mars that might have had water in the recent past, but not any of the actual biology study.
So when you were looking at Mars, this is Mars from a satellite point of view, perhaps looking at the geology of Mars itself, correct?
Right. So I started working on a satellite called the Mars Reconnaissance Orbiter, and I worked in operations for two of the cameras aboard there, the context camera, or CTX, which takes really large panchromatic, so grayscale images of the planet at 6 meter resolution, which means you can resolve things about the size of a school bus on the surface. And then another camera called the Mars Color Imager, or MARCI, which takes full color mosaics of Mars at 1 kilometer resolution. So it's pretty low res, but we take these images every single day to monitor the weather on Mars. And that way we can look at how the weather patterns are changing over time. If there's any weather that might be impacting any of the landers or rovers that are on the surface. And we use it to pick future landing sites because we don't want to send something to a place on the surface that always gets dust storms, for example. We don't want to end up like, Matt Damon in The Martian.
And comparably, from what type of imagery and what type of satellites you used for looking at Mars, comparably, what kind of resolution is that compared to something like Landsat or maybe some of the high resolution satellites that you're dealing with Planet?
So the context camera, it sits somewhere in between Planet and Sentinel-2. So Sentinel-2 is 10 meter, Planet is 3 meter, and CTX is 6 meter. So it's right in the middle there. But we don't get color imagery with CTX, unlike Planet or Sentinel-2. The MARCI camera is lower resolution than even like Landsat or MODIS, but we're not really using it to look at the surface. We're only looking really at the atmosphere and large scale changes in what we call albedo patterns. So if you look at Mars through even a really rudimentary telescope, if it's close enough, you can see that there are light areas and dark areas. And those are just differences in how much dust is on the surface in any given spot. So the darker areas are less dusty than the brighter areas. And that changes over time when you have dust storms and things like that. So we watch how those patterns change every year after the dust storm seasons come and go.
Is there a specific area of Mars that you focused on the most?
So my studies were pretty global. I was focused on a particular landform called gullies, and these are small channels that are carved on slopes, mostly the walls of impact craters, in the middle and high latitudes in both hemispheres. And so I spent many years looking at over 70,000 CTX images of the planet and mapping out where all of these gullies were and their orientations to try and figure out how they might have formed. Because the idea when they were discovered back in the late 1990s was that these were formed by flowing liquid water on the surface of Mars in the relatively recent past. So geologically speaking, tens to hundreds of thousands of years. And then in 2006, we found out that some of these were actually active today. We saw places where there were new flows of material through these channels. And so they became this hot topic in Mars science. How do you have things flowing in these channels that look like they were carved by water during a time in Martian history when liquid water shouldn't be stable on the surface for any long periods of time? And from that, people thought that there was a huge climate influence on how these might have been forming. So I mapped them all out across the planet to try and figure out what was going on. So instead of focusing on a particular place, because we had this camera that took these giant high resolution images to do global studies, we were able to look at everything rather than just saying, I'm going to focus on this one crater or this one area.
Well, I feel like you left a little bit of a cliffhanger there. Did we ever figure out what that is, or is that study still ongoing?
I published the results of it a few years ago. The ideas are still a little bit debated in the science community. The general consensus seems to be that the channels themselves were originally carved by probably melting snow or ice that collected on the walls of these craters back when Mars was tilted at a different angle to the sun than it is today. So right now, the Earth and Mars are both tilted about 25 degrees toward the sun. And so the ice distribution on the surface is really similar. Mars has polar caps like we do, and it has ice in the higher latitudes. But the Earth wobbles on its axis by a couple of degrees, and Mars wobbles on its axis about just 60 degrees. And so when it wobbles, the ice moves on the surface. So the ice that's at the poles today ends up migrating to what is now the equator. And then as that tilt goes back, the ice retreats back up toward the pole. And that retreating area is where we find all of the gullies. So probably there are a remnant of that ice retreating. But then the stuff that's flowing through the channels today might just be bits of stuff that are lubricated by frost. And then as that frost starts to sublimate, so it goes directly from solid to vapor without ever it doesn't go through the liquid phase, it forms a little bit of gas underneath the particles of dirt that are stuck in those channels and lets them flow downhill. So you have a combination of some traditional processes, stuff we would see on Earth, and then some more exotic processes, because we don't tend to have these gas lubricated flows unless you're looking at something like a pyroclastic flow out of a volcano, and that's at a completely different scale, completely different velocities. Like you need a volcanic eruption to make that happen.
Well, and then that overlaps with my next question is with how you look at Mars, how translatable is it looking at Earth, right? You just pointed out some very unique things studying another planet.
In general, Mars and Earth are really similar. Mars has volcanoes, river channels, lakes, a lot of the kind of stuff you see on the Earth. So that's how we know that probably in the ancient past, Mars was a lot more like Earth. It had a lot more water flowing all over the surface, but then something happened to turn it into this pretty dry, arid, cold place that we see today. Mars is a cold polar desert. But there are some things on Mars that are a little bit trickier to explain. For example, a lot of features on the surface of Mars are much larger than they are on Earth, and the difference in gravity between the two planets isn't enough to explain that. So the gravity on Mars is about 38% out of the Earth's. The volcanoes on Mars are typically very, very massive. Mars has the largest volcano in the solar system, which is 3 times taller than Mount Everest, and the base of it is about the size of Arizona, so it's absolutely massive. Mars also has gigantic polygonal terrain in the higher latitudes, so this is something we see a lot in the Arctic on Earth, where you have freeze-thaw action in the soil, and it kind of pushes boulders out to the edge of these polygon shapes. But the ones on Mars are orders of magnitude bigger than the ones on the Earth, and we can't figure out mechanically how to explain why they're so large. So we have ideas of how things form on Mars because we have these analogs on Earth, but there's still some weirdness that we don't know how to explain yet.
So you would say that, I think I've heard occasionally that Mars is a dead planet. It's far from it. It's a very active planet, right?
It is. I think most people assume it's just this dead red rock floating out in space, but we see a lot of activity. And I think the Mars Reconnaissance Orbiter is what really opened our eyes to that, because before we just got snapshots. We didn't have a lot of repeat coverage, and we didn't have enough aerial coverage to really get these complete pictures. But with the Mars Reconnaissance Orbiter, we discovered things like avalanches of dust and ice coming off the edge of the polar caps. And we caught those as they were happening. So we see these dust clouds kicking up off the edges of the polar cap. So we're flying over while avalanches are happening, which really blows my mind. We see new impact craters forming all the time. We can see dust devils darting across the surface and leaving tracks behind. All sorts of stuff like that. And so it's really cool to be able to see how dynamic Mars actually is. It's still much less dynamic than the Earth, comparatively speaking, but compared to pretty much any other rocky body in the solar system, Mars is pretty active.
I think this is a good time to bring up a question from the chat room. As one of the individuals has pointed out, there's some conflicting information about whether or not Mars has tectonic plates, and that goes into the topic of geomorphology, correct?
Yeah, so I think there's a little bit of confusion when we talk about tectonics, because there isn't any evidence that Mars had plate tectonics like the Earth has, but there was tectonic activity on Mars. So we see things like extensional fractures. We see places where you've had stuff that's moving around, but we don't have anything like plate tectonics where plates have crashed into each other, or subduction zones or anything like that. As far as we can tell, there isn't any other body in the solar system that has undergone plate tectonics besides the Earth, with the exception of maybe Jupiter's moon Europa, which has some kind of funky ice tectonics going on. So you have plates of ice that are interacting with each other. But in general,
not to get off of side topic too much, but do you think that would have to do with just the tremendous amounts of gravity issues going on with a planet, with a moon going around a planet that size?
Oh, for sure. You have a combination of that, and then you have the ocean that's inside of Europa. So you have something that's lubricating this action, combined with Europa is just getting squeezed like crazy as it goes around Jupiter.
Great. And talking about other planets, beyond Mars, what would you, and beyond Earth, what would you say a good planet is to study within our solar system, and why would that be important?
So other than Mars, I have a soft spot for Enceladus, which is one of the moons of Saturn. And Enceladus is really, really cool because it has geysers shooting out of its south pole. And these are geysers that are shooting out bits of water ice and organic material that we were able to observe with the Cassini mission. And there's so much of this material that is spewing out of the south pole of Enceladus that it has actually made an entire ring around Saturn. So if you Google Saturn E ring, you'll see a lot of really beautiful pictures of this gossamer looking ring that is really diffuse compared to what you normally see when you look at pictures of the rings of Saturn. And that is all stuff that has just come out of this moon. And so we think that this is forming from there's internal heating inside of Enceladus. It's created this pocket of liquid water only at the South Pole for some reason. And then there's a set of what we call the tiger stripes, which are these fractures that are warmer than the rest of the planet. And that's where these geysers are coming out. So we know that we have warm liquid water with organic material in this spot. And those are all the happy conditions that you need on Earth, at least, for life to thrive. So I think that Enceladus is a really great place for us to look and see if we can find any of the building blocks of life, or maybe even some kind of microbial life that's hanging out there right now.
So you did mention organic material in that sense. What does that exactly mean?
Organic material just means that it has carbon in it. I think this is another thing where sometimes the media gets a little bit confused. Like, we've discovered organic material on Mars, for example, but it doesn't imply that there's life there. It just means that there is something there that had carbon in it, and it's a thing that is useful for life, but you don't need life to form organic material.
Okay, no, that's a great clarification, so that answers that about studying a moon of Saturn. So my always favorite was studying maybe Europa or something like that, like you mentioned earlier. But Saturn's unique. I don't think that it gets enough credit for for what's there.
Yeah.
So just to kind of back up a little bit and talk about the imagery as it applies to Earth for a second. High resolution satellites are being developed and being released year after year right now, right? Focusing on Earth. Planet's a good example. Maxar has a lot of high resolution imagery as well. Do you see any use for high resolution imagery in other planets? You mentioned the low resolution imagery of Mars. You think we might push a high resolution image satellite out there too?
So we already have a high resolution camera on that same satellite. It's called HiRISE, the High Resolution Imaging Science Experiment. And it takes 25 centimeter per pixel images in panchromatic, so black and white, and 1 meter image, 1 meter resolution images in color. So the footprint of that is really small. So that's why CTX is called the context camera. It takes these larger images that are meant to be the context for these smaller footprint high-rise images. So if you've ever seen any of the really gorgeous color images of Mars that are not from the rovers that have come out over the last decade plus, it's probably something from HiRISE. We also have a 50 centimeter imager around the moon called the Lunar Reconnaissance Orbiter camera. And with that, we've been able to see things like all of the landing sites for the Apollo missions. And you can even still see the tracks that the astronauts walked, like between the lander and, say, instruments that they set up. And you can see tracks where they drove around the rovers on the moon as well, which is really cool. It's like if you ever needed proof that we were on the moon, you can see all of it at all of the landing sites with this camera.
No, that's impressive. And actually, that resolution is just as good, if not better, than a lot of the imagery satellites here on Earth, between 0.25 meters and, you said, 1 meter imagery. So that's impressive. Just it's very comparable. And so kind of getting into, I want to talk briefly about a plug for your book, For All Humankind. Tell me a little bit about that, what it is, and just the insight you gained from it.
Sure. So I was always interested in how the Apollo missions impacted the rest of the world. And when Neil Armstrong and Buzz Aldrin walked on the surface of the moon, one of the things that they did was they read aloud the text on a plaque that's on one of the legs of the lunar lander. And the plaque says, "Here, men from the planet Earth first set foot upon the moon, July 1969. We came in peace for all mankind." And there are a lot of other pieces that are associated with the mission that reflect peace. The eagle on the mission patch is carrying an olive branch. The mission carried a small microscopic disc with messages of goodwill from leaders all around the world on it, most of them in their own languages. And so it made me wonder, whenever we hear about the Apollo mission in the United States, it tends to be with a very patriotic lens. America beat the Russians to the moon. This is something that we did as Americans. But what did the rest of the world think? What was the lens like in this thing where the mission was being broadcast as this accomplishment for all of humanity? And so I sought to find people from around the world who either watched or listened to the moon landing live as it happened, but grew up outside the United States. And I specifically didn't want to talk to people that work for NASA or in the space program in general, because we've heard those stories before. It's really common to find people that say they were inspired by Apollo to become an astronaut or become a planetary scientist. But I wanted to know how this affected school teachers in India, or just, an average person from Africa. How did this event impact all of these people? And so I managed to track down 8 people across 5 different continents, ranging from the age of 5 at the time of the landing to 44. So huge range of backgrounds, ages, expertise areas. And the theme that came out from all of them, this is a bit of a spoiler, so I hope you guys still want to read the book anyway. But the common thread across all of them was that all of these people felt like this was a human achievement. They didn't care that it was America versus the Russians, generally speaking. They just thought it was amazing that humans had the ability to build this stuff and go to the moon and walk on another body in the solar system. And a lot of them felt like they were part of it, even if they were something like, we have a young boy who grew up in Iran, and he felt like he was part of this mission, even though he was just a child and was not connected to the space program in any way other than the fact that he loved reading science fiction. And so it was really fantastic to see across all of these different backgrounds of people that they felt like this was something where we came together as a species and accomplished something amazing. And it made me wonder, what's next? Like, what is our next Apollo moment that will bring people together again for something good and happy, to realize that we can accomplish amazing things?
What do you feel like that next Apollo moment could be?
I've been thinking about it a lot from this experience, and I've had a really hard time coming up with an answer, because I think part of the interview process left me a little bit pessimistic, just thinking about how disconnected we all are today. Everybody's brains are firing at 20 different things a second, and people aren't really necessarily aware of what's going on around the world or even in space. And I give a lot of talks all around the world, and I get serious questions from people who ask if I've been to space, if The Martian was based on a true story, if there are people living on the moon right now. They're not aware that we haven't gone back to the moon. They're not aware that we've never gone to Mars. So in terms of space, I don't know what the next thing will be. Like, if we go back to the moon or we send our first human mission to Mars, I don't know if we have the ability to be brought together in the same how our attention spans are now compared to 1969. But
So
I
you
really
feel like
hope
so this, in some ways, do you feel like science fiction, although is tremendously inspired our culture for space, but it also could have watered down the motivations and understanding of what's really going on?
Oh, it's an interesting way to word it. Possibly. I think there's also just a little bit of a disconnect between fiction and reality, in ways that it's a little tricky to overcome right now. But like I said, I'm hoping that I'm wrong. Maybe when we do send the first humans to Mars, and if it's a truly international mission, it's not just America is going to Mars. It's, hey, this multinational effort between America and Canada and the European Space Agency and India and Japan. If they all come together to have this mission, I think that would be very impactful. But I'd be curious to see how people react to it, given the 21st century mindset of all the other things that are going on in our lives.
Do you think it's more of a motivation if there's some type of economy or industry behind it, such as asteroid mining, or perhaps, or should we just shoot for the Mars and establish a colony? Does that make any sense?
I mean, having some kind of commercial motivation definitely helps in terms of funding. You know, like Elon Musk has SpaceX to try and send humans to Mars, and that is his sole goal for basically everything that he does. So it depends on if you are doing something for commercial benefit, or you're doing something because you already have the finances, but you want to better humanity by creating this base on Mars, or are you doing it for scientific exploration? So do you have the space agencies of the world come together to create an outpost on Mars where they're doing research, kind of like what we do in Antarctica right now? I don't think there's a right or wrong answer necessarily. I would just love to see us get there one way or the other. So I'll take whoever can get us there first, provided they, do it in an ethical way.
That makes sense. We haven't left Earth from an orbital standpoint since the moon landings, so it'd be nice to move forward.
Yeah, definitely.
No, thanks for that insight and an overview of your book. And we'll have links to your book within the show notes. Once again, that's For All of Humankind. I think that's a fascinating topic. I'd love to understand what individuals' perspectives were during the time of the moon landing. And it's incredible you were able to interview all those individuals, considering how old they were at the time. You mentioned the range all the way up to 44. That's incredible.
Yeah, he was a Holocaust survivor who now lives in Toronto. So his perspective is incredibly powerful because, as he put it, he's lived through the worst of what humanity is capable of and the best of what humanity is capable of. And I thought that was a really striking message, to think about how much one person can go through in their life and see such a wide range of things.
That's great. Now, I want to pivot slightly towards away from the space topic for a second and talk about women in science. And I want to talk about the challenges for women in science from your perspective and advice you would like to give young women. For example, I have 2 daughters. One of them's not interested as much in space, but she's very mathematically inclined. The other one's very interested in space, especially at a very young age. So I'm hoping they stay in it, but I want to hear your thoughts on that.
So we still have a lot of work to do in terms of women in science. The gender balance is getting better. There are definitely more women in the field, and I see it when I go to conferences now. You can look at the audience, and there's a huge gap between sort of older male-dominated age group and then the younger generation, where it's much more gender diverse, much more ethnically diverse. Like, you can see the wave of change that's coming through the community. And we're seeing pretty good numbers in terms of women graduating with degrees in STEM-related fields. But we have what's often called the leaky pipeline. So women tend to be driven out after graduation by things like sexual harassment or biases against women, the attitude that some places take toward women wanting to have families. And so we need to be working together to make the community itself more welcoming to women so that we don't lose people for these reasons, because you have people that have incredible ability, but then they just feel like the field isn't meant for them to stay. And so they leave and they go do something else. But I do feel like in the time that I've been in the field, it's gotten better. But it's not perfect. So I'm hoping, by the time your daughters are old enough to come into this, these won't be conversations that we have to have anymore, because everybody will just be accepted for who they are and their ability, and we can just, move things forward.
Well, maybe it would help if, can you talk about some of your career inspirations along the way that have gotten you where you are today?
The biggest ones were just following active missions. So I got really interested in Mars because of the Pathfinder mission, which landed on Mars in 1997. And this was a lander that had a small rover inside of it. And so when it landed on Mars, the lander unfolded and the rover drove out of it. And so there's all these wonderful pictures from that mission that are pictures from the lander watching the rover drive around on the surface of Mars. And I thought that was so cool, because that was the first rover we'd ever sent to another planet. And being able to remote control a rover on a planet that was 200 million miles away blew my mind. And I really wanted to be involved with that. And so I just started tracking down anybody that I could to see if they could help me figure out how to do this as a job. I approached the local chapter of the Mars Society in Seattle, where I was living at the time. And a lot of people that were in that were computer programmers, or they were engineers with Boeing and different aerospace companies in the Seattle area. They hooked me up with people at the university, like different professors and students that I could talk to there. And so I just really proactively went out and sought out advice from people. I was like, hey, this is what I want to do. How do I do that? And so that's the advice I tend to give people if they're interested in getting into space or anything nursing, really. It's like, if you see people doing what you want to do, don't be afraid to approach them and say, hey, what you do is really cool. Like, how can I do that? Because I think in general, if there are folks like me and most of the people I know who are really excited about what we do and we love it, we want everybody to come and be nerds with us. So we would love to tell you how to do it so you can come and be part of our group.
No, that's great inspiration. I think everybody needs a little help understanding how to accomplish their dreams. Not just from what classes should I take in college, but just understanding the career path. Like, okay, you have this job, but what did it take for you to get there? And I think there's always a missing part of that story from trying to find that dream that someone might have at a young age.
And it's generally not a linear path either. It's not, most people I know, the story isn't like, I went to college, I took these classes, I applied for a job when I graduated, and I got that job. It's much more complicated than that. And so hearing everybody's stories and realizing that there's not a single path, I think is really, really helpful, because so many students, if they feel like they're having trouble or things aren't going really smoothly, they start to feel like they're a failure, like they're not cut out for this. And then they hear stories from people like, I had to take calculus 4 times before I passed, mostly because I was really sick at the time. But I think telling stories like that to let people know, like, hey, it's not an easy thing, or it's not a straightforward thing, is really helpful. So you can see all the different ways there are for you to reach the end goal that you have.
Well, I just have a couple more questions before we wrap up. The first one is, what is your favorite science fiction story, book, movie? And is there one that most relates to real science that resonates for you?
Ooh. Specifically in terms of real science, I have to say The Expanse. They've done such a great job at getting a lot of things scientifically accurate in ways that add to the storyline really well. So, like, especially with the show, it's just absolutely stunning. And yeah, I think hands down from a science standpoint, I'd vote for The Expanse.
That's awesome. That's one of my favorites right now as well. I'm glad Amazon picked it up. And next one is, right now, what do you like about studying Earth through imagery?
Earth is really beautiful, and I think it's really powerful to be able to see in satellite images the impact that humans have every single day. When I hear people that don't believe in things like climate change, I think it's because they don't think that something as small as a human can impact something as large as the Earth. But when you look at these satellite images from space, you can see how much we impact the entire planet every single day. And everywhere you look, even if you're in the middle of Siberia or the middle of the Sahara, there's generally something that you can see that tells you that humans have been there, or humans have done something that affected it. And that's a really powerful thing in good ways and bad. But the fact that you have this lens that you can't really argue with, it's like this agnostic observer looking at everything that's happening on this planet. I just find that really, really amazing.
That makes total sense. As an imagery analyst myself, I think that's one of my most, fascinating light bulb moments, is watching the Earth for so long and then realizing how much, just like you said, humans have impacted it in so many different ways. Watching the change in activity, the development of civilization itself over so many areas of the Earth. And I think the only other folks who have a greater, almost just perspective of that is an astronaut themselves. When they see that, that beauty from orbit, it brings a certain level of mystique, but also watching it through the satellites, I think we get a very unique perspective ourselves on how things change.
Yeah, definitely. And these images are a way for everybody to be their own astronaut, even briefly, getting that overview effect and seeing the planet without borders and without politics, and just seeing it for what it is. And I think that more people should just sit down and browse through satellite images of the Earth and really take the time to appreciate how wonderful it is.
More Google Earth, right?
Yeah.
So any last minute shout outs you'd like to give, whether it be your company, projects that you have going on, or anything going on in the world that you'd like to talk about before we end the show?
I guess if anybody wants to learn more about Planet, you can go to planet.com, and there's lots of information there, and you can take a look at some of our images. And if you have any questions about Mars, or you just want to nerd out about Mars or anything space, you can find me on Twitter as @Tanya of Mars, and I'm there tweeting all the time.
Well, thank you very much. This is Dr. Tanya Harrison, aka Tanya of Mars, planetary scientist. I'm Adam Simmons with Project Geospatial. Thanks everybody for listening. Signing off.